The ultimate developer laptop. Huh. Really? This, of course, is the Framework Laptop 13 Pro. I've been a pretty happy developer on my MacBook Pros for the last 13 years or so, and when Framework announced what they're building is essentially what Macs couldn't accomplish, a modular laptop that runs Linux that's as good as a MacBook Pro. The MacBook Pro for Linux. So as soon as they announced it, I ordered it. I'm kind of glad I did because prices went up. And while I was waiting, anticipating, I'm not really gonna rhyme in the rest of this video, I promise. I wanted to know if this will actually be able to be something I can use as a Linux laptop, as a developer. And I'm sure all of you wanna know too. I don't expect one AI prompt to build an entire project for me. In reality, I'm constantly moving between models depending on the job. GPT for research, Claude for coding, Gemini for massive context, Nano Banana, Midjourney, Flux for images, and then I've got Seed Dance and Kling for video. That's why Chat LLM by Abacus AI makes sense. It brings day one support for the latest GPT, Claude, Gemini, Grok, DeepSeek, and more in one place the moment they drop. Pick any model from the interface or let Route LLM automatically choose the best model for each prompt. Create professional presentations with graphs and charts and deep research detailed content. Need human sounding copy? Humanize rewrites text to defeat AI detectors. Need visuals? Pick frontier or open source models. And when you need more than chat, Abacus AI Agent can help build complex apps and websites, connect payments, or run 24/7 agents that keep working through longer tasks. The best part is app hosting. Backend database and auth support comes with the subscription. All that starts at just $10 a month, way cheaper than paying for all those subscriptions separately. Check out chatllm.abacus.ai or click the link below. Wow, it's thin. Oh, that's just the bezel. You get a little screwdriver. Modules for USB-A, DP, HDMI, Ethernet, USB-C, and micro SD. I got them all, baby. SSD, LP cam. This is pretty interesting. This is the battery. Speakers, fan, made with love by the Framework team. All right, 1 terabyte drive. Placed gold. That's the memory. Guess now we need this. That's metal. I guess I just popped that in, huh? Wait a minute. I'm not done yet. Wait. We need this thing too, the bezel. There is a little bit of a give in the lid, but the fact that it's metal gives me a little bit more confidence. And it weighs pretty much just like a MacBook Air. I've got Fedora installed and I need to update it. Huh. Oh. Ethernet. This is the 10 gig one, and I'm online. And we've got an Intel chip that wasn't supported on that version of Fedora, so I just updated it and then it worked. In fact, Framework recommends you use Fedora 44, not 43 or 42. Now this is the M5 MacBook Pro, and I just wanted to see them side by side and run a few tests because that's what you all want to see probably. It is nice to see a non-Mac machine besides the Surface Pro have a haptic trackpad like this where you can press it anywhere and the tap will be registered. The keyboard is something I'm not used to on the Framework. However, it is a slightly longer travel and that might actually be easier for typing because when I'm on the office and I'm on a desktop or remoting in, I use a mechanical keyboard sometimes where the travel is a lot more. So this feels a little bit closer to that than the membrane on the MacBook. But the space bar is pretty much the same. They even sound very similar. Let's see, how do I... Oh yeah, I want to get HDMI output. I like that. Now it is an Intel-based chip, so I will plug it in order to do some of these tests. But just before I do, I'm gonna run Speedometer 3.1. Basically shows you how responsive web applications are going to be on the machine, whether you're developing them or you're the end user. And since these are all JavaScript-based applications, there's to-do applications, there's charting libraries, Angular, React, Vue, things like that. Everything is basically a single-threaded operation here because JavaScript is single-threaded. So we're getting 12.5, which is not the most impressive thing I've ever seen. That's better. 30.8. So yeah, I'm gonna keep this thing plugged in, but that's nothing new. That's just the way Intel chips have been for a long time now. I'm gonna set it to performance mode and see if there's any fan noise that pops up. Nope. This time, let's race these two machines. Now, it's very difficult to beat the M5 chip in single core performance. In fact, I got 60.6 over here, and here on performance mode, I got 37.3, which is actually very nice. Let's see if HDMI works. There it is. It comes up as a second screen and I can drag stuff to it. Now you might be wondering why I'm comparing the MacBook Pro M5 to this laptop, to the Framework 13 Pro. And that's because they both have Pro in the name, obviously. Well, also it has to do with price. because these two, the starting price is about the same, very close. MacBook Pro starts out at $2,000. This is for the 14-inch, so it's just an inch bigger. Yeah, just a tiny bit bigger screen than the framework. I'll pick black, I'll pick standard M5 chip, because if we go to the M5 Pro, we're at $2,500. It's $500 more than the framework laptop starts. So I think that's kind of a different kind of comparison. Unified memory starts at 16 gigabytes on the MacBook. We're gonna configure the framework Pro DIY edition, and we're gonna go with Intel because that's about $200 cheaper than the AMD 300 series. And if you go with the Ultra 5 Intel, then you're in the MacBook Air territory. So you're $800 less than the MacBook Pro starts, which is actually pretty good. That's just the starting price though. We're gonna configure it a little bit more and it's gonna get up there. This version is the Ultra X7, which brings our price to $1,699. We're still below the starting price of the MacBook, but then we gotta add memory. So LPCAMM 2 is gonna bring this up to about the same price as the MacBook, just a little bit under, but we still need storage. MacBook gives us 1 terabyte. So let's select that. And now we're above the MacBook price. We're at $2,153. But I'd say that's considered pretty much within the same area. Plus or minus a couple $100 is not a huge deal considering all that you get with this one. You get options, bezel, keyboard, power adapter. They're gonna charge you for a power adapter, but it's a 100-watt power adapter for $60. So that brings the price up a little more. The MacBook includes a 70-watt power adapter, and you can modify that to a 96 one for $20 extra. And I will do that just to get it a little bit closer to the power of the framework one. That's all the configuration you get with the MacBook. So we're at $2,019. But with the framework, you get expansion cards, which you can get or you don't have to, but you should probably have some if this is your first one. If this is your second one, then you might just use the old ones. USB-C, I'll grab one of those. Actually, let's grab 2 of those because, well, the MacBook has 3 actually. So let's go with 3. That's $30. Graphite, orange, and red. I don't know. Don't judge me. I want a USB-A one just in case I'm carrying one of these mice around and I don't feel like connecting with Bluetooth. I want to have that handy because that's good backup option. I do want an HDMI. That's $22. And Ethernet is nice to have. So I normally order that, but I won't do it just for the price comparison sake. Finally, the MacBook does have an SD card, so let's add one of those. That's $25. We are at $2,277 compared to the MacBook's 2019. So the MacBook is actually cheaper now. So that's pricing. But did I mention that framework also gives you more options? Like, eventually, I hope to be able to select this Ultra X9. It's out of stock, but maybe eventually it will be available. It's in the same machine. Memory, you can go up to 64 here, and these LPCAMM modules actually go up to 96 if you can find one. Here, you can only configure it with 64, but you don't have to buy it at all. You can just order it somewhere else if you want to. Save the $1,600, like if you have a side deal going on somewhere, or eBay, grab yourself a 96 gigabyte chip and you're set. But if I raise this up to 64, we're over $3,000 now, $3,600. And the MacBook doesn't even give you that option because the M5 chip only supports up to 32 gigabytes in memory. If you want to go with a 64, you would need to upgrade to an M5 Pro chip. So let's do that. Now we got a different chip in here and our price is $3,699. Pretty close. Now the framework is cheaper. Every time you clone a repository or install dependencies or open a project, you're hitting the SSD. Now the SSD with the MacBook is the way it is, but with the framework, we can pick different kinds of SSDs we want to use. With the framework, I got the SanDisk SN7100, and that's Gen 4. 7100 and 7200 on the M5 for read and write, and 5800, 5600 for read and write on the framework. The read and write speeds are pretty good. They're not as high as on the M5, but those are sequential read and writes. The random read and writes is what matters a lot for doing development. You're reading and writing a lot of little files here and there when you're doing compilations. And that number is really impressive on the framework, especially on the write speeds. Even an M5 Max model doesn't come that close. This is my M5 Max on the side here, and these are the numbers. Now, since we're talking about JavaScript, this is the web tooling benchmark. I sometimes run this. It's basically an oldie but a goodie. Look at that. 8 years ago is when it was updated, but it still works fine. Clone the repo, install the npm packages, build it, and let's race. Boom. Got both of these machines running now, and I'm expecting, since this is JavaScript again, I'm expecting the MacBook to win, but by how much? We've got Babel, 25.8 runs per second on the framework. Here, 34.18 runs per second, so quite a bit faster on the MacBook there. I guess this will surface the single core performance of that M5 chip quite nicely. But we also got to do some real builds and multi-core tests, so stay tuned for that. TypeScript 31.6 on the framework, TypeScript 46.65. Those are the ones I really care about, and the geometric mean is much higher on the MacBook, 37.18 and 26.36 on the framework. Now, how will these machines handle multi-core using all their cores to the max in a Python interpreted test? Let's check that out. For that, I got the Mandelbrot test, which I commonly use on the channel here. It's written all in Python, and it pegs the cores to the max. And this is a race. Let's go. Check out that CPU load on the MacBook. Those are the green lines marching up and down here, filling up all the cores. There's 10 cores here. And this is what it looks like on the 16 cores of the framework laptop. Definitely filling up those cores, but you can hear the fans. Oh yeah, definitely hear those fans. Hopefully it pays off. And the framework actually beat the MacBook here. I ran that a couple times. 30 seconds is the MacBook average. Don't quote me on that average part. I know somebody will say something. And we got about 23 to 25 seconds here on the framework. And it is that core difference. We have 10 cores on the MacBook, 16 on the framework. And since this is a multi-core program that utilizes all those cores, the framework is going to do better. Which means that anytime you're going to have a compilation of code, that's going to use all the cores. The framework is probably going to be faster. Now, this test did peg every single core synthetically, but what happens when we take a look at a real compilation? This is Damien Edwards, who is a software architect on the .NET team at Microsoft, and he had this thing called DevBench. I have my own little benchmarks that I run for development purposes that are .NET and C# related, and I took a look at this one, and it's good because it's got all these different options like warm builds and cold builds and incremental builds. So I thought, hey, I'll check it out and use it. And I take a look at benchmarks, and one of the benchmarks, the big large .NET compile benchmark that I always show on my channel is here. It's mine in his repository. So I feel honored here to be part of this repository. And now I'm going to use DevBench to do the tests here. This has slightly more variation. So I'm going to run this, and what this lets me do is select which test I want to do. So let's say I want to do Hello World. It's a very short one, small .NET application. Boom, let's go. So test the cold build, the warm build, and the incremental build. We have results. Cold build on the MacBook is 836 milliseconds. Warm is 294, and incremental is 335. Definitely faster than on the framework. Cold build 2,172 milliseconds. Warm 446, and incremental 491. What about that huge build, the one with 100,000 namespaces and classes that I created before? That's now part of this one. Boom. This one takes a little bit longer. Oh, in case you're curious, I do have this on my GitHub. It's this project right here, and this is how it generates the code. I actually generate the code using Python, but I make sure that the C# compiler can't optimize away, and it has to build every single thing. Oh, I'm hearing the fans. I mean, it's not loud, but I can still hear them. Things are happening. Let's see what's happening with the thermals here. We got about 45 on the MacBook, up to 47. And what's going on here? Where's the hotspot? The hotspot's around the same spot here on the framework. And we're a little cooler here. 43, 44, just a couple of degrees. And we have our results. Cold build, 85 seconds. Let's just call it seconds. It's in milliseconds, but whatever. 54 on the framework, much faster on the framework this time. And the warm build, 10.5 seconds on the M5. 7.9 seconds on the framework. This is where more cores pays off when you have slightly larger projects like this. And there's one more in here, which is a build of an actual CMS called Orchard Core. This is as real as they get as far as projects go. Let's try that one out, because that's the one that's not faked. It's real. I mean, I didn't fake the other ones. It's just that they're more of a synthetic kind of thing. Hello world, who's gonna write that? This one, they're very close. Cold build is faster on the framework just by a couple of seconds. And the warm build and the incremental build are very close. They're within half a second. It's time to move on and talk about AI. I know, your favorite topic, right? Well, for some of you it might be, but this machine has that LP-CAM memory in it. LP, by the way, that's the same kind of LP that's in this laptop, LPDDR5X. And this one has LPDDR5X also, but it's in the LP-CAM format, which means you can swap it out. Apple solders the same exact memory onto the chip, so you can't swap it out and upgrade it later. This one you can. But other than that, it's the same memory. And memory is very important when it comes to AI workflows, LLMs, image generation, because memory bandwidth, or how much throughput memory can do, that's what determines how fast it can generate tokens. So let's check memory bandwidth with this good old Stream benchmark. And I say good old because it is pretty old. You can find the code on GitHub, but it's been around for a long time. Look at this website. Yeah, it's all HTML. And the Stream benchmark, boom, measures the memory bandwidth. It's got a triad of things that it measures. One particular thing is the copy command. This is very important when it comes to LLMs. 136,000 megabytes per second is what we have on the M5. Now, Apple quotes 150, but this is the more realistic number here. And we pay a slight penalty for not having those chips soldered on. Now, on the Framework laptop, we get 97,000 megabytes per second. So yeah, it is actually slower, but you get to go up to 64 gigabytes, you get to go up to 96 if you want to, and you get to be able to swap it out. That's the push and pull of the whole thing, right? But let's see how this actually affects LLMs. I'm gonna fire up LM Studio, and it's not gonna work very well. I'm gonna warn you that ahead of time, and I'm gonna explain why. I'm gonna load up Gemma 312B by Onsloth. It's the 4-bit quantization, and same thing over here. Now, we're not gonna go too deeply into prompts here and different kinds of prompts, different lengths. I'm just gonna issue something simple so we can see that even if I say hi here and hi here, we have a significantly different speed here. And this doesn't even make sense. We're less than half the speed on the Framework laptop than we are over here on the Mac. 15.6 tokens per second on the Mac for the same model, same prompt, and same quantization, and 6.2 tokens a second here on the Framework. What is going on? And you'd think, oh, maybe it's just not running on the GPU. Well, actually it is. Here, let me run it again and tell it to write a story so we can capture it. And there it is. Look at that. It's running on the GPU with 93, 94% utilization. Notice that the GPU is sharing the memory, that LP-CAM, with the CPU. 62 gigabytes available for the GPU to do its work. We can run larger models, way larger than on this MacBook with 16 gigs of memory. But why are we getting this slowdown? Well, this has to do with that Intel chip inside there. And it's not that the Intel chip is bad, it's just that it's too new. LM Studio doesn't yet support that architecture. So for now, we have to use a different build of llama.cpp that's not yet supported in LM Studio. And you can do that. You can go to llama.cpp on GitHub, build it. It's pretty easy actually, but you have to include SYCL support. SYCL is the underlying API that's available for Intel that's gonna allow it to run faster. Otherwise, it's gonna run Vulkan. Vulkan is another kind of API that runs across all the platforms. So Vulkan can run on AMD, it can run on Intel. But remember, when you're first customizing your Framework laptop, you have the option to pick Intel, the brand new Ultra Series 3, which is Panther Lake. Support is probably coming soon, or you can pay $200 more and get the Ryzen AI 300. Not that it's a better chip, it's an older chip, but it has more support, and Vulkan will work pretty well on that, as well as the AMD libraries. Here I'm gonna run llama.cpp, and this is the SYCL build. I'm gonna point at the exact same model, same quantization. Boom, let's go. There it is, and it's generating. And this is using the GPU again. If we take a look at that, there it is. It's up to 97% now, 99%. So the utilization of the GPU is better here because of that optimized software. Still, it probably could be better. We got 9.9 tokens per second here, which is not quite 2 times faster than it was with Vulkan. So even though we saw a 40% difference in Stream benchmark, the difference in generation here is more like 50 to 55%. So what happens when we want to run a larger model? Well, on the Mac, this is a 16 gig machine, so I can't even run this Quant Coder 30B. It's likely too large, and that's true. Even the 3-bit quantization is 15 gigabytes. But of course, you'd need to buy a larger machine, if you want to run the larger models. The 16-inch machine, not the 14. I'm just kidding. I mean larger memory. But this one has 64 gigabytes, so I'm able to run the larger models. Here's token generation using Vulkan compared to Sickle. And as you can see, Sickle is much faster. Quant Coder 30B is down here, 22 tokens per second with Vulkan and 34.9 tokens per second with Sickle. That's pretty nice. What I didn't expect is the prompt processing. And this one is a little bit confounding because I haven't found this pattern before in my testing, where the prompt processing is actually faster in Vulkan than it is with Sickle, except for Quant Coder, but this looks like an anomaly. It doesn't follow the pattern of the other models. Unfortunately, I don't know of a way that you'll be able to use prompt processing using Vulkan and then token generation, the second part of inference, using Sickle. Once you've loaded that model up using one stack, you kind of have to use this same stack unless you want to use twice the memory amount, and that's just not feasible. So the framework, it's an interesting machine and it's solidly built. It feels premium. It feels like it's quality. As far as performance goes, it's somewhat there. Is it going to be able to do all your development related tasks? Probably, most likely. Am I going to be trading in my M5 Max, my daily driver, for the framework? No, I won't be, but that's also an $8,000 laptop, way more powerful. If I had an M5 MacBook Pro and I needed a Linux machine, this is an easy trade. Even though the M5 is an integrated system and it can do a lot of the tasks that we did slightly faster, except for the multi-core stuff, which is actually the more realistic workflows. This one does all that. I can see this framework being my dev machine, and that's why I'm gonna keep a close eye on this. I think they've come a long way. This is an impressive device. And this is my first look at it. So if you have any questions, write it down below. I'll probably be back doing more reviews on this. And if you want to see Windows on this thing, I didn't really want to, but maybe some of you do. Let me know in the comments down below. Now, this is just the base M5 MacBook Pro. If you want to see the comparison of this one with the M5 Pro and the M5 Max, watch this video here. Thanks for watching, and I'll see you next time.